Welcome back, everybody. In this video I'm going to talk about radian and degree measure and angles and arcs. Now let's say we have an arc, say right here. Now an arc is basically the area that connects those 2 points right here, and then we have 2 radii sticking out right here from the origin. Let's say that this is R and this is R here, and then this is S, which is the arc length. This is the angle that is between R here and R here. If we have a case like this where R is equal to S, we can say that R is equal to S. An angle that initially starts from here and starts to gain measure, it starts to gain what we call radians, and it corresponds to theta right here. So the equation for that is presented right here can be simply written as theta is equal to S over R, where theta is measured in radians, S corresponds to the arc length, and R corresponds to radius. If we were to make a full revolution around the circle, we'd go arc by arc. So an arc here, and then an arc there, and then so on and so forth until we completed our one revolution around the circle. So we know that the circumference of a circle is given by 2 pi r. This is the circumference of a circle. Now we know that pi is roughly around 3.14. So one revolution around the graph would give you 2 times 3.14, which is roughly 6.28. This 0.28 right here is this area right here. So if we go 1 arc here, or 1 radian, we go 2 radians here, 3 radians, 4 radians, 5 radians, 6 radians, and then 0.2 radians right here to complete one full revolution around the circle. Another important concept I'd like you to keep in mind is that on a graph, there are 4 infinitely divided sections called quadrants. I'm telling you this now as you're going to need to know what it means later, as it will be useful to solving many problems in trigonometry. So on the graph, this section is called quadrant 1. This section is quadrant 2, 3, and then 4. Now this is just a brief sketch of what quadrants look like on a plane. It's not necessarily that your teacher could write it for you. You could definitely find that in your textbook or online. However, it's pretty important to know where each quadrant is to solve other future problems. Now when an angle starts to increase, it goes counterclockwise. So if we have an angle right here, when it starts to increase, it goes counterclockwise. And it gains measure, which we discussed, called radians. The side it ends with on whatever quadrant, let's say, let me use purple again. Let's say if an angle starts here at 0 and gains measure, let's say the angle is 75 degrees. So 75 degrees will be somewhere here before the 90 degrees. So, or we can just shade it right here. If this is 75 degrees, the measure of that angle, or actually, instead of saying 75 degrees, let's say 60 degrees, yeah? So 60 degrees is equivalent to pi over 3 radians. This is a concept I'm going to teach you in another video, but for now, just know that 60 degrees is equivalent to pi over 3 radians. So when an angle starts to gain measure and ends up at 60 degrees or pi over 3 radians, the side in which it ends with is called the terminal side. So this side right here is called the terminal side. The terminal side. And then the side that the angle started with is called the initial side. Again, important concepts. It's good to keep those in mind in case you encounter questions. So, keeping this in mind, let me erase this here. If I were to construct another graph right here, so let's say an angle starts to gain measure, okay? Let's say it's gaining measure until it encounters the first, let's say the first line, the positive y-axis. So if we were to say that we went a quarter of the way, just because this graph is divided into 4 sections, we can say that we went a quarter of the way of the graph. And since this whole circle is 2 pi, we can say that if we went a quarter of the way times 2 pi, that's going to give us 2 pi over 4, which is pi over 2. So this area right here, this positive side of the y-axis, is pi over 2 on a graph. If we were to go half the way of a full circle, so a semicircle, what we could do is we could multiply half times 2 pi. That's just going to give us pi. And pi actually lies on the negative side of the x-axis. If we were to go 3/4 of the way from where we started, so 3/4 times 2 pi, that's going to give me 3 times 2 pi is 6 pi. Then we have 4 at the bottom. And if we simplify, we're going to end up with 3 over 2 pi. And actually, 3 over 2 pi does lie on the negative side of the y-axis. Then if you go a full revolution, you're going to end up with, you're going to end up at 2 pi. So if we go 1 full revolution and multiply it by 2 pi, you are going to get 2 pi, which is where you actually started with. Another concept I like to talk about is coterminal angles. Let me just erase this here. Now, 2 angles are considered to be coterminal if they have the same initial and terminal sides. Or in other words, 2 angles are coterminal if they end up on the same position on the coordinate plane. And every angle basically has a positive and a negative coterminal. To find those angles, you must either add 2 pi or 360 degrees or subtract 2 pi or 360 degrees. For instance, say you have this graph right here. I don't know if it's straight or not. Say you're given an angle, let's say 60 degrees. So you're given 60 degrees lies somewhere here. This is 60 degrees. If you were to find 2 coterminal angles for 60 degrees, you would need to add 360 degrees and subtract 360 degrees from 60 degrees. So 60 degrees plus 360 degrees is going to give you 420 degrees. 60 degrees minus 360 degrees is going to give you negative 300 degrees. So what does this mean? What is this actually saying? Well, at 60 degrees here, if you go one full revolution around the graph from the position you started at, which is 60 degrees, if you go one full revolution, you're going to end up at an angle of 420 degrees. So you're basically starting here and ending up right where you started. So at 60 degrees, if you go 360 degrees, you're going to end up at a new angle, 420 degrees. However, it is the same exact position as 60 degrees, meaning you can say that 420 degrees is a coterminal angle of 60 degrees. Likewise, for negative 360 degrees, if you go the negative direction, so instead of going counterclockwise, you go clockwise. So if you go here all around and stop where you started, you basically went negative 360 degrees and ended up at negative 300 degrees, which is the same position as 420 degrees and 60 degrees, meaning negative 300 degrees is a coterminal angle of 60 degrees and 420 degrees. One more example. Say you have 2 pi over 3. 2 pi over 3. Now, 2 pi over 3 is excuse me, 2 pi over 3 on a graph would be somewhere, if pi over 3 was right here, which is 60 degrees, 2 pi over 3, another 60 degrees would be 120, which is still before 180, so it would be somewhere here. And then another pi over 3 would just be 3 pi over 3, which is just pi. So we should, this rough sketch kind of looks pretty accurate. So if 2 pi over 3 is right here, somewhere here, if we added 360 degrees, or 2 pi in this case, we're going to end up going counterclockwise again, back to the same position we started with. So 2 pi over 3 plus 2 pi, well, if we were to use the least common denominator, 2 pi over 3 corresponds to 6 pi over 3. 2 pi over 3 plus 6 pi over 3 is going to give you 8 pi over 3. 8 pi over 3 is a coterminal angle of 2 pi over 3. So if you were to go 2 pi radians from 2 pi over 3, you will end up at a new angle, which is 8 pi over 3. Now, if you were to subtract 2 pi over 3, excuse me, if you were to subtract 2 pi from 2 pi over 3, you're going to end up with a negative 4 pi over 3, meaning if you go clockwise, which is in the negative direction, two pi radians, you would end up at the same position you started with. This would be negative 4 pi over 3. So two coterminal angles of 2 pi over 3, which are negative 4 pi over 3, excuse me, and 8 pi over 3. So that's it for this lesson. I hope you enjoyed it. A lot of concepts here, a lot of things to keep in mind. Trigonometry is a very a very nice subject, to be honest. It can get a little tricky, but you know, you just gotta go through it. Just do as many problems as you can. Practice coterminal angles. Practice how to practice radians and degrees. Within the next couple of videos, I'm going to go deeper into radians and degrees, and we're going to actually learn how to switch or convert between radians and degrees. A very important concept required from all students. However, if you do like this video, please give it a thumbs up. Don't forget to subscribe to my channel. This is going to help grow the channel more. Feel free to leave a comment in the comment section below if you have any questions or concerns, and we'll see you in the next video.